Hello, Engineering Sem 2 students. This is Ashish Charania, and I welcome you to this one-shot video where we are going to master full module 1 of your Applied Mathematics 2, which is differential equations of first order and first degree. It is roughly 15 to 18 marks out of your entire 80 marks university M2 paper. So it's a significantly high weightage, and this video is roughly going to be 2.5 hours long. If you just give this much time to me, if you just give 2.5 hours long, I guarantee you will be able to answer and master the full differential equations of first order and first degree, and you will be able to answer every question that comes up in your university paper. Okay, without wasting much of time, let's get into the video. Let's look at what is the form of exact differential equation. Exact differential equation is a differential equation which is written in the form mdx plus n dy is equal to 0. Okay, that's the form or format of exact differential equation. Here, both m and n, both are functions of x and y. Okay, m is a function of x and y, and even n is a function of x and y. Okay, remember that. Now, there is a condition that should satisfy in order for the equation to be considered exact. Okay, what is that condition? Let's look at that. So the condition is you take two derivatives. You take partial derivative of m with respect to y. You take partial derivative of m with respect to y, and you take partial derivative of n with respect to x. Okay, if these two derivatives come out to be equal, such a differential equation is called exact. So, okay, so this is the condition. If this is true, if true, differential equation is exact. Okay, so that's how you checked if the differential equation is exact or not. If the differential equation is exact, the solution of such a differential equation is given by integration of m dx plus integration of n dy is equal to 0. That's the solution of that exact differential equation. Now, there is a thing that you have to keep in mind here. There is a small thing that you have to keep in mind here. In order to integrate m, whenever you integrate m, remember that m is a function of x and y and n is a function of x and y. Both are different functions of x and y, but essentially they are functions of x and y. When you are integrating m, remember, which is with respect to x. Okay, we are integrating m with respect to x. Remember that you have to keep y as constant. Remember, you will treat y as constant. And when you are integrating n, the one thing you have to keep in mind, since you are integrating with respect to y, you only have to take the terms free from x. Take only the terms free from x. Since you are integrating with respect to y, you have to take the terms free from x, and in order to integrate m, treat y as constant. If you remember this rule, you will be able to solve every question of exact differential equation. Okay, we'll look at few examples. Let's start by looking at example. Now let's convert this equation in terms of m dx plus n dy. Just cross multiply this. So therefore we have so dy times this term. So I have sine x plus x cos y plus x times dy plus this times dx. So y cos x plus sine y plus y into dx. This is equal to 0. Now remember that this is of the form m dx. Whatever is with dx is m. So this is your m and this is your n. Okay. So now we need to find two derivatives here. Okay, we need to find two derivatives. I'll first write the values. So I have m is equal to y cos x plus sine y plus y. Okay, and I have, let's first differentiate. All right, let's just write the value of n. N is sine x plus x cos y plus x. Okay, I have those two values. Remember, we need to take two derivatives. We need to take derivative of m with respect to y. We have to take partial derivative of m with respect to y. And then we have to take partial derivative of n with respect to x. Okay, the partial derivative of m with respect to y. Remember, with respect to y, x is constant. So if you want to differentiate this, cos x is constant. So you have cos x. Derivative of y with respect to y is 1. Plus derivative of sine y with respect to y is cos y, plus derivative of y with respect to y is again 1. Okay. So essentially you have cos x plus cos y plus 1. Okay, that's the derivative, partial derivative that you have. Now let's try to find another derivative, which is the derivative of n with respect to x. Derivative of n with respect to x. Now let's differentiate sin x. Derivative of sin x with respect to x is cos x plus x cos y. Remember, y is constant. When you're differentiating with respect to x, y is constant. So you have cos y times derivative of x with respect to x is 1 plus derivative of again x with respect to x is 1. So if you notice, this is the same thing. You have cos x plus cos y plus 1. Okay. So you have those two equations. Notice that those two are equal. Notice that since delta m by delta y is equal to delta n by delta x, therefore our differential equation is exact. Because that condition is satisfied, we can say that differential equation that we have is an exact kind of differential equation. Okay. In order to integrate or solve the exact differential equation, the solution that I have is, therefore, solution that we learned is, solution is, solution is integration of m dx plus integration of n dy is equal to 0. That's the solution that we know of. Okay. Now here we have to integrate m, but remember that while integrating m, we have to treat y as constant, okay? Because we are integrating with respect to x, we'll treat y as constant. And while integrating n, we have to remember we have to take the terms free from x. Because we are integrating with respect to y, we have to take all the terms free from x. Let's look at how to integrate it then. So we have integration. Let's substitute m. So we have y cos x plus sin y plus y. Y cos x plus sin y plus y into dx. Okay. Then we have plus integration of, we have to take all the terms free from x. If you look at n, if you look at n, is there any term which is free from x? Sin x is not free from x cos y is not free from x, and even x is not free from x. There is no term in this n which is free from x. So there is no term that we can include here. So we just write 0 dy. Okay. Because remember, we only take the terms here which are free from x, free from x. Okay, in this case, we don't have any term which is free from x, which is why we cannot take anything. So it's 0 basically. Okay, so which is equal to 0. Okay, also let's add a constant of integration c. Let's add a constant of integration c. Now, therefore, we are integrating here, remember, with respect to x, so y is constant. So you can just write y. Integration of cos x with respect to x is sin x plus integration of sin y with respect to x. Remember, sin y is constant. So sin y is also constant. Whatever left is 1. So integration of 1 with respect to x is x plus, remember, integration of y with respect to x. Y is constant. Integration of 1 is nothing but x, because there is, when you take y as constant, whatever is left is 1. Okay. Plus 0 is equal to constant of integration c over here. Okay. So therefore, your solution will become y sin x plus x sin y plus xy is equal to constant of integration c. Since there is a constant of integration c, remember that this solution is called as general solution. This solution is called general solution. Okay. If they would have given the value of x and a value of y, what we would have done is found the value of c and substitute it here. Then we would have got particular solution. Okay. But since they have not given any condition or values of x and y in order to find the value of c, we can just leave our answer here. Okay. I hope that makes sense. Let's move on to next example. In the next example, I have, it's already, if you notice, in the form of m dx plus n dy. It's already in the form of m dx plus n dy. Let's see if this is exact. Let's write the value of m first. So m is y into 1 plus 1 upon x plus cos y value of n is x plus log x minus x sine y. Okay. Now let's try to find derivatives of partial derivatives of m with respect to y and n with respect to x. So let's take partial derivative of m with respect to y, partial derivative of m with respect to y. So with respect to y, x is constant. So this 1 plus 1 over x is constant. Derivative of y with respect to y is 1 plus derivative of cos y with respect to y is minus sine y. So basically what I have is 1 plus 1 over x minus sine y is my delta m by delta y. Now let's see if what I get for delta n by delta x. Delta n by delta x. So with respect to x, derivative of x with respect to x is 1. Derivative of log x with respect to x is 1 over x minus, remember with respect to x, y is constant. So sine y is constant. Derivative of x with respect to x is 1. So if you notice both the terms are same, 1 plus 1 over x minus sine y. So therefore we can say delta m by delta y is equal to delta n by delta x. Since those two partial derivatives are equal, therefore we can say that our differential equation is exact. Our differential equation is exact. If our differential equation is exact, the solution that we can find, the is solution is integration of m dx plus integration of n dy is equal to 0. Okay. Remember that here we have to take the terms free from x. Take the terms free from x. And here you have to treat y as constant. Y as constant. Always remember those rules, okay? So therefore you have, let's substitute the values. So we have integration of m. Let's take m. So m is this y times 1 plus 1 over x plus cos y. So I have y times 1 plus 1 over x plus cos y. Okay, and this whole thing is getting integrated with respect to x plus integration. Remember, in n, we only have to take the terms which are free from x. So let's see, terms free from x. Again, here, x is not free from x, log x is not free from x, there is x here. Even x sine y is not free from x because there is x here. So we only had to take the terms which are free from x. So there is no term here which is completely free from x. Everything has x in it. So which is why again what we have to do is we just have to take 0 over here. Okay. In the next example, we'll see there will be a term which is free from x, and we'll take that term. Okay. Now let's integrate this. And actually, let's add a constant of integration c since we have already integrated. Okay. Now with respect to x, let's integrate this term and this term. With respect to x, remember y is constant. Okay. Remember y is constant. So you can write y times integration of 1 with respect to x is x plus integration of 1 over x with respect to x is log x. Okay, so that's the integration of this part. You keep y as constant and you integrate 1 and then you integrate 1 over x plus integration of cos y with respect to x. Remember, y is constant. If y is constant, cos y is also constant. You don't have to integrate it. You can just write it the way it is. And then whatever left is 1. So integration of 1 with respect to x is x is equal to add the constant of integration c, and that can be called your solution. Such a easy question it is. Okay, they give you 4 marks for this. Okay, in your exam they get such questions, you get for 4 marks. All right, let's look at next example. Let's look at next example a little bit where you have to do some work in order to differentiate and everything. Let's look at it in detail. First of all, you understand that this is your m, this is your n. Okay, you have your m and n ready. So let's write it down. Let's say your m is equal to y square into e raised to xy square plus 4x cube. Okay. Uh, and your n is, let's actually write it here only. N is equal to 2xy e to the power xy square minus 3y square. Okay, so we have our m and we have our n. Let's see if this differential equation is exact anyway. Let's try to find the partial derivative of m with respect to y. Partial derivative of m with respect to y. So let's start to differentiate this. If you notice this y square and e raised to xy square, you'll have to use UV rule or the product rule of derivatives, which says u derivative of v plus v derivative of u. Okay. So in other words, in order to differentiate this, you first have to keep y square constant, derivative of e to the power xy square is e to the power xy square into derivative of xy square. Derivative of xy square, you are differentiating with respect to y. So x is constant and derivative of y square is 2y plus. Now this is u derivative of v, okay? And then we have v, so e to the power xy square into derivative of u, okay? So which is y square, derivative of y square with respect to y is 2y. And 4x cube derivative with respect to y is 0, okay? So that's just 0 because x is constant. With respect to y, x is constant. So we have this will become 2xy cube e to the power xy square plus 2y into e to the power xy square. Let's say those are the two terms. Now let's differentiate n with respect to x. Let's differentiate n with respect to x. Now with respect to x, y is constant. So this 2y is constant. So we can write it the way it is, 2y. Let's put a bracket. Let's put a bracket. And we have x into e raised to xy square. So that means we'll have to again use product rule or UV rule in x and e raised to xy square. So first we'll keep x the way it is. We'll keep x the way it is. Derivative of e raised to xy square. E raised to xy square. Derivative is e raised to xy square into derivative of xy square with respect to x. Y is constant. So y square is constant and derivative of x is 1. I hope that makes sense. You'll have to know the UV rule in order to do this, okay? Plus. Now, e raised to xy square constant, e raised to xy square, keep it constant, and take the derivative of x. So derivative of x with respect to x is 1 minus derivative of this with respect to x is again 0. I hope that makes sense because derivative of y square with respect to x is 0. So therefore we have just multiply this 2y inside, multiply this 2y inside. So we have again 2xy cube, this y and y square will become y cube, e raised to xy square, e raised to xy square plus 2y, this 2y inside, e raised to xy square. So therefore, since those two values are, if you notice, equal, this value and this value is exact same, that means that derivative of m with respect to y, that means therefore derivative of m with respect to y is equal to derivative of n with respect to x. Since these two derivatives are equal, therefore we can say our differential equation is exact. And since it is exact, the solution is, since it is exact, the solution of the differential equation is integration of m dx plus integration of n dy is equal to 0. I hope that makes sense. So therefore, remember that here, while integrating m, you have to keep y as constant. And here, take the terms free from x. Free from, only take the terms which are free from x. So x shouldn't be there here. Okay, so let's see. All right. So now let's substitute the values of m and n. So we have integration of, if you look at the value of m, we have y square e raised to xy square plus 4x cube, y square e raised to xy square plus 4x cube into dx plus. Remember that in n we only have to take the terms free from x. If you only take the terms free from x, so if you notice here, this first term contains x, so we cannot take this term. Only this term is without x, minus 3y square. So we'll only take that term. We'll only take minus 3y square, minus 3y square dy. is equal to, let's add a constant of integration c. I hope that makes sense. So now we have integration. Let's integrate this with respect to x. With respect to x, y square is constant. Let's integrate that. So with respect to x, y square is constant. Integration of e raised to x y square is e raised to x y square. Remember that we have to divide by the coefficient of x. Here x is the variable. Coefficient of x square is coefficient of x is y square. So in integration, we always divide by the coefficient of variable. Whatever the variable is, coefficient of that we divide by that. Okay. Plus, let's keep 4 constant. X cube, integration of x cube is x to the power 4 divided by 4 minus 3 y square. Integration of y square is y cube divided by 3 is equal to constant of integration c. Let's cancel this, cancel this, and we have the solution e raised to xy square plus x to the power 4 minus y cube is equal to constant of integration c, and this is your general solution of this differential equation. I hope that makes sense. We solve non-exact differential equations by converting them to exact by finding something called as integrating factor. Okay, let's look at what we mean by this. Let's say the differential equation that we want to solve is of the form m dx plus n dy is equal to 0. Okay, here remember that m is a function of x and y, and even n is a function of x and y. M and n both are functions of x and y. Okay, if the differential equation was exact, derivative of m, partial derivative of m with respect to y, and partial derivative of n with respect to x, these two partial derivatives would have come out to be equal. But if the differential equation is non-exact, that is what we are looking at right now, we will see that these two partial derivatives won't be same. So first thing that we'll do to solve is to find those two partial derivatives, just like we did in exact. We'll find those two partial derivatives, delta m by delta y and delta n by delta x. And if they come out to be non-equal, we know that differential equation is non-exact and we have to reduce it or convert it to exact. What are the steps to convert it to exact? There are some rules that we follow that we'll learn about shortly, but there are some steps to follow. Okay, step number one is using the rule, using the rules that we will learn. Find the integrating factor. Find integrating factor. What are the rules? We'll just look at it in the next slide. Okay, but remember, using the rules, find integrating factor. Next, next step is multiply by integrating factor. Multiply by integrating factor on both sides. Multiply by integrating factor on both the sides. Okay. And step 3, equation is now exact. Once you multiply by integrating factor on both the sides, equation becomes exact. Equation is now exact. Solve as usual. Solve as usual. We'll just solve like we solve exact differential equations that we learned in the previous video. Okay, we'll still look at that in detail even in this video. Okay, let's look at the rules. The important thing that we want to learn now is what are the rules to find integrating factor? What are the rules that we use to find integrating factor? Now there are 4 rules that we have to remember in order to find integrating factor. Rule number one, if delta m by delta y minus delta n by delta x, you take that difference. You take the difference of two derivatives, delta m by delta y minus delta n by delta x, and you divide that by n. You divide that by the latter term, n. Okay. If this whole term is a function of x, if this whole term is a function of x, so if delta m by delta y minus delta n by delta x divide by that n function, is if this whole thing is a function of x, then that implies integrating factor is e to the power integration of fx dx. Okay, that's the rule number one. If we notice that this difference divided by that n is a function of x, then integrating factor is e to the power integration of fx dx. That's the integrating factor. Rule number two is very similar to rule number one. Okay, it's just the reverse of this. Okay, if so, instead of taking delta m by delta y first, if I would have taken delta n by delta x, minus delta m by delta y. Can you guess it? We divide it by this term, second term, m. If this come out to be, if this whole thing come out to be a function of y, okay, a function of y means it doesn't contain x, okay, here function of x contain means it doesn't contain y. If this come out to be function of y, you can guess that integrating factor is equal to e to the power integration of fy dy. Very simple. Rule number three is, let's say if equation is of the form m dx plus n dy is equal to 0, that's the normal form of the differential equation that we solve. But here m is, so here since it is dx, if m is y times function of xy, y times, note that this is not x comma y, this is function of x into y, okay? So if m is y times function of xy and n is x times some other function of x into y, okay? If this is the situation that m is y times, if it is dx here, it should be y times for some function of xy, and for n it should be x times some function of xy. Those two are different functions, f1 xy, f2 xy. If this is the scenario, then our integrating factor is 1 upon mx minus ny, 1 upon mx minus ny. Remember that since mx minus ny is in the denominator, it cannot be 0, where mx minus ny is not equal to 0. That's our integrating factor. Okay, the last rule. Again, if the equation m dx plus n dy is equal to 0, if equation is of this form, m dx plus n dy is equal to 0, and from here, if you try to find dy by dx, and if you try to find dy by dx, and if dy by dx is homogeneous, if dy by dx is homogeneous, okay, we'll look at what is homogeneous while solving the questions. But if dy by dx is a homogeneous function, if dy by dx is a homogeneous function, then our integrating factor will become 1 upon mx plus ny. Integrating factor will become 1 upon mx plus ny, and where mx plus ny is not equal to 0, obviously, because it's in the denominator. These are the 4 rules really of finding the integrating factor. Very simple so far. Okay, now let's look at some examples. Okay, remember that these are the rules to find integrating factor. So that's step number 1. Using rules, we find the integrating factor. Step number 2 is multiply integrating factor on both the sides of the differential equation. And once you do that, the moment you do that, the differential equation that you have will become exact, and we'll just solve it like an exact differential equation that we have done in the previous video. Okay, very easy steps to follow. Now let's look at this example. We have m dx plus n dy. So this is of the form m dx plus n dy, where if you notice m is equal to xy square minus e to the power 1 over x cube, and our n is minus x square y. Okay, don't forget that minus. We have minus x square y as our n. We take two derivatives as always. We take derivative of m with respect to y. Okay, derivative of m with respect to y. With respect to y, x is constant. Okay, derivative of y square is 2y, and minus derivative of this with respect to y is 0, because this is a function of x. Okay, so we have 2xy. Okay, derivative of m with respect to y is 2xy. Now let's look at derivative of n with respect to x. Derivative of n with respect to x. With respect to x, y is constant. With respect to x, y is constant. Derivative of x square, even minus is constant. Derivative of x square is 2x. So we have minus 2xy. So those two are not equal. Delta m by delta y and delta n by delta x. Those two are not equal. That means the equation is not exact. But we can reduce it to exact. How can we reduce it to exact? Let's take the difference delta m by delta y minus delta n by delta x. Okay, let's take that difference. So if you take the difference, this is 2xy minus 2xy is equal to, so this will become 4xy. This will become 4xy. Notice that now what you have to observe is that the moment you calculate the difference, the moment you calculate that either difference, if this is the difference, you divide by n, and this, if this is function of x, then this is the integrating factor. So now if you notice this, if I divide this value by n, is that a function of x? If I divide that by n, is that a function of x? Or if I divide that by m, will that become a function of y? Okay. If you notice, if you divide these two, the y and y will get cancelled. The y and y will get cancelled, and this will become function of x. But if you divide this one and m, nothing will get cancelled, and it won't be a function of y. Okay, so you have to actually see that if you the difference that you have got, if you divide it by either m or n, are you able to obtain a single function of either x or either y? Okay, so here I notice that therefore delta m by delta y minus delta n by delta x, if you divide that by n, if you divide that by n, we get 4xy in the numerator, and the denominator is minus x square y, and things will get cancelled here, and you will get minus 4 upon x. You will get minus 4 upon x. So this is a function of x. Okay, this is a function of x. If this is a function of x, we know that this will follow rule 1. We know this will follow rule 1. Okay, and the integrating factor is e to the power integration of x fx dx. So integrating factor is integration of e to the power integration of fx dx. So this is equal to e to the power integration of minus 4 upon x dx. Okay, this will become e to the power minus 4 is constant, can be taken out of integral. Integral of 1 upon x is log x, or ln x, natural log of x. Okay, all right, that makes sense. Now this minus 4 can be taken in the numerator by log property. Sorry, not in the numerator, in the power of that x. Okay, so this will become, let me scroll a little bit down. So this will become e to the power log x to the power minus 4. By property of log, this minus 4 can go on top of that x. So this will become, now since this is e, and this is, since a natural log, the base is also e. Okay, for natural log, the base is e. If this value and this base e is equal, we know that these two kind of get cancelled, and we are just left with x to the power minus 4, which is nothing but 1 upon x to the power 4. Now that is our integrating factor, 1 upon x to the power 4. The moment we find integrating factor, we have to multiply. If you remember the steps, we have to multiply by integrating factor on both the sides. We have to multiply by integrating. So we take the differential equation, we multiply by integrating factor. So let me just copy that differential equation. Let me just copy that differential equation, and we paste that differential equation down. Okay, and we multiply both the sides by integrating factor. So I just write multiply by integrating factor on both the sides. So you get therefore 1 upon x to the power 4. So you get 1 over x to the power 4 xy square minus e to the power 1 upon x cube times dx minus 1 upon x to the power 4 x square y into dy is equal to 0. Now we know, once you multiply by integrating factor, this is an exact differential equation. At this point, this is an exact differential equation. Let's just simplify this a little bit. Just multiply this inside. So we have y square divided by x cube, y square divided by x cube minus e to the power 1 upon x cube divided by x to the power 4 dx minus, this will become y upon x square dy is equal to 0. Okay, now this is, since we know that once you multiply by integrating factor, the differential equation is exact, we can just say that solution is, integration of m dx plus integration of n dy is equal to constant c. That's the solution. But remember now that this is your m and this is your n. Okay. Also, one thing, if you remember from the previous video, that in m we treat y as constant, and here we take the terms free from x. Terms free from x. Okay. Very easy so far. All right. Let's treat y as constant and integrate. So we have integration of y square upon x cube minus e to the power 1 upon x cube divide by x to the power 4 times dx plus integration of, take only the terms free from x. N is this. Take the terms free from x. There are no terms which are free from x. If you notice, there is only one term in n. In n, we have y upon x square. So here in n, we only take the terms free from x. Since in n, there is no term which is free from x. There is only one term which contains x square. Okay. So this will just become 0 dy is equal to constant c. I hope that makes sense. Uh, Now let's try to solve that integral. Remember, in the first integral, we treat y as constant. Okay. So we have integration of, split that integration, y square upon x cube dx minus integration of e to the power 1 upon x cube divide by x to the power 4 dx. Okay. And this is equal to constant c. So therefore, y is constant. So we have y square integration of 1 over x cube dx. Okay. And in the second integral, we have to do method of substitution because this is a composite function. If you put 1 upon x cube as t, 1 upon x cube as t, somewhere you will get 1 upon x to the power 4. Okay. We'll have to do method of substitution that we have studied. So like actually, let's first do that. So let's say here, let 1 upon x cube, let's say that is t. So therefore, differentiate this with respect to x. So you get so this is just like x to the power minus 3 is equal to t. Now differentiate with respect to x. So you get minus 3 x to the power minus 4 is equal to dt by dx, right? Just using normal differentiation technique. So therefore, I have minus 3 upon x to the power 4, because this x to the power minus 4 can be written as 1 upon x to the power 4. This is equal to dt by dx. Therefore, here we need to find dx divided by x to the power 4. Okay, so just take this dx over here. So we have dx divided by x to the power 4 is equal to minus dt upon 3. Okay, so that's the equation that is left over to me. So now what do we have? So we have here in the first integral, y square is constant, can be taken out of integral. Okay, we are left with integration of 1 upon x cube dx minus, we can convert this now in terms of t. We have integration of e to the power t. We just have e to the power t over here. And this dx upon x, we have dx upon x, sorry, dx upon x to the power 4 is minus dt upon 3. So this is minus dt upon 3. Remember that t is 1 upon x cube, and this is equal to c. Now, very simple integral at this point, y square integration 1 upon x cube can be just written as x to the power minus 3 dx, and this negative will become positive integration 1 upon 3 can be taken out, e to the power t dt is equal to c. All right, very easy so far. So therefore we have, therefore y square x to the power minus 3, the integration is x to the power minus 3 plus 1 upon minus 3 plus 1 plus 1 upon 3. For integral e to the power t, we know integral is e to the power t is equal to constant of integration c. So therefore we have y square x to the power minus 2 over minus 2 plus 1 upon 3, and we know that t is equal to 1 upon x cube. So t, we can substitute 1 upon x cube is equal to c. If we want, we can simplify this a little bit. So therefore we have Therefore, minus y square upon 2x square. This x to the power minus 2 can be taken in the denominator, plus 1 upon 3 e to the power 1 upon x cube is equal to constant of integration c, and this is our solution. I hope this makes sense to all of you. All right. All right, let's look at this next example. We have, this is our m, we have, this is our n, right? Uh, so we have m is equal to 2x y to the power 4 e to the power y plus 2x y cube plus y, okay? And our n is x square y to the power 4 e to the power y minus x square y square minus 3x. Okay, let's take the difference or the derivatives of m with respect to y, and let's see what do we get. Now with respect to y, x is constant. With respect to y, x is constant. So we have 2x which is constant. Now we have to take the derivative of this with respect to y. Okay, so we'll have to apply the product rule or the UV rule here. Okay, so we have y to the power 4 constant. Derivative of e to the power y is e to the power y plus e to the power y constant, and derivative of y to the power 4 is 4y cube. Okay, plus we have, this is 2x is constant again, and the derivative of y cube is 3y square, plus here the derivative of y is 1. Okay, here since x is constant, 2x we kept as constant, and we differentiate y cube as 3y square. Okay, so just simplify this a little bit. So we have delta m by delta y is equal to 2x y to the power 4 e to the power y plus this 2x times this. So, and then that will become 8 actually because of that 4 and that 2. So that will become 8 x y to the power 3 into e to the power y plus we have 6 x y square plus 1. Okay, so that's the derivative of m with respect to y. It does look a little bit scary, but I promise you that it will be very easy once we solve it. It is not that difficult. Now let's take derivative of n with respect to x. Let us just highlight that derivative of m with respect to y is what we found. Let's take derivative of n with respect to x. So we have with respect to x, y is constant. So these two terms are constant. So we have y to the power 4 e to the power y. Derivative of x square over there is 2x. Derivative of x square is 2x because with respect to x, y is constant. Again, with respect to x, y is constant. So we have y square. Again, derivative of x square is 2x minus derivative of 3x is 3. Just simplify this a little bit. So we have delta n by delta x is equal to y2 x y to the power 4 e to the power y minus 2x y to the power 4 minus 3. Okay, so that's the value that we have. First thing that you do always is take the difference. You either take the difference of delta m by delta y minus delta n by delta x, or you take the difference of delta n by delta x minus delta m by delta y. Doesn't matter. Just take one difference and divide by either m, first divide by m and then divide by n and see what happens. Okay, let's see what happens. Let's first take the difference. Let's first take the difference of therefore, delta n by delta x, the value will become delta n by delta x will become 2x y to the power 4 e to the power y minus 2x y square minus 3. Okay. So in the end, we have to figure out whether it is rule number 1 or rule number 2 in this case. So basically, we have to figure out whether you have to divide by n or whether you have to divide by n. If you divide by n and it turns out to be function of x, then it is of this rule 1. If you divide by m and it is function of y, then it's rule 2. What you do, it's just the difference of two. It's the reverse difference, but it doesn't matter for now. It's just the difference. Okay. So for now, let's take a difference between those two derivatives. Sequence for now doesn't matter. We'll figure it out later. But for now, let's just take a difference. Okay. We are just figuring out. So I'll just use a different pen. Let's just use delta m by delta y minus delta n by delta x upon n, and maybe let's just calculate two values. Okay, let's just calculate delta n by delta x, delta n by delta x minus delta m by delta y divided by m. Let's see which of those two it is. Okay, let's see which of these two it is. If you take the difference of delta, so if you take a difference, this first term and the second term will get cancelled anyway. The second term you write, so 8x y cube e to the power y. Okay, I'll just circle whatever is done. So we considered this and this. Okay, then we have this. We considered this 6xy square minus 2. So we have plus 8xy square. So we considered this. Then we have plus 1 minus 3. So we have plus 4. Now divided by n. What is n? Divided by n. Let's just copy the value of n for now. Let's just copy the value of n from here and just paste it here. Let's see if anything is getting cancelled over here. Even if you take x common from here, I don't think anything will get cancelled. X y to the power 4. So this is not going to get cancelled. Okay, anyway. So that means let's discard this case and let's focus on this one. So let's just take the reverse difference. Okay, if it just take the reverse difference, it will just be a negative sign. Okay, so this will be minus 8 because it's you are essentially doing a minus b, you are just doing b minus a. So the result will be just negative of this. Okay, in the numerator. So 8xy cube e to the power y minus 8xy square and minus 4. And in the denominator, let's paste the value of m now. And let's see what will happen. Something magical is going to happen now. Let's copy that. Oops. Let's copy that and paste it over there. Paste it over there. And then if you take y common, so you get uh, 2x y cube e to the power y, okay, plus uh, 2x y square. Notice the pattern is coming out. The terms are same, plus 1. In the numerator, just take 4 common. In the numerator, just take actually minus 4 common. If you take minus 4 common, you'll be left with 2x y cube e to the power y minus, or sorry, plus, since you are taking minus common, 2x y square plus 1. If you notice, this term and this term will get cancelled and you will be left with minus 4 over y, which is a function of y. Now that we understand this is the second type, okay, which is delta n by delta x minus delta m by delta y. So let's just rewrite those things with a clean pen. Now that we know, that's what you'll do in exam too, okay? Just use the rough side of the page, use like a rough side of the page to to make a decision between that, okay? To make a decision whether it is delta m by delta y minus delta n by delta x or delta n by delta x minus delta n by delta y. So in this case, it is delta n by delta x minus delta m by delta y divide by m. Okay, and we already learned we got minus 4 over y. Okay, I'll just re-substitute everything here. So we have n by x. So this minus this will get cancelled. Minus 2, and this will become minus 8 x y square. This will become minus 8 x y cube e to the power y, right? And this will become minus 4. And in the denominator, we have m, which is essentially, we can just copy this really, copy that, paste it here. Oops, it didn't copy the entire thing, but in the end, we have plus y. Okay, let's take minus 4 common. So we have 2xy square plus 2 xy cube e to the power y plus 1. In the denominator, again, let's take y common. So we have 2xy cube e to the power y plus 2xy square plus 1. Okay, so this and this will get cancelled, and we have minus 4 upon y, which is a function of y. Okay, which is a function of y. So since this is a function of y, we can now say that therefore integrating factor is e to the power fy dy. Let's just write it in the next line. We can say that integrating factor is e to the power integration of fy dy, e to the power minus 4 integration of 1 upon y dy, because we just can take minus 4 common inside the integral. So we have e to the power minus 4 log y, okay, which is equal to e to the power log y to the power minus 4. This minus 4 can just go in the power of log by the property of log, okay. Now since this is a natural log, the base is e, okay, so that the whole thing will get cancelled and we have y to the power minus 4, which is 1 upon y to the power 4, okay. Now that we have integrating factor, we can take the original equation and multiply that integrating factor on both the sides. So let's just copy the whole original equation. Let's just copy the whole original equation. Copy that, paste it here down, paste it here. Now multiply both the sides by 1 upon y to the power 4. So you can just write divide by y to the power 4, because you are basically multiplying integrating factor on both the sides. So just multiply by y to the power 4 on both the sides. I hope that makes sense. Now that you multiply y to the power 4, which is the integrating factor on both the sides, remember that the equation is now exact. Now that we know that equation is exact, we can just uh, do the solution as usual. Before that, let's just simplify this a little bit, and this will become therefore 2x e to the power y plus 2x divide by y, just splitting this y to the power 4 here, plus 1 upon y cube. Okay, this y and this y to the power 4, 1 upon y cube times dx, plus we have y to the power 4 here, so we'll get cancelled. So x square e to the power y minus x square divide by y square, okay, minus 3x divide by y to the power 4 dy is equal to 0, okay. That's our differential equation, which is exact. So the solution is, now that it is exact, solution is integration of m dx plus integration of n dy is equal to constant of integration c, okay. Remember that in the first term we have to keep y as constant, and in the second term take the terms free from x, okay. Take only the terms which are free from x, free from x, because we are integrating with respect to y. Take the terms free from x, and here with respect to x just treat y as constant. So let's see, what do we have. We have integration of m dx, so just substitute the value of m. This is m, okay. 2x e to the power y plus 2x divide by y plus 1 upon y cube into dx. Take the terms plus integration of, only take the terms free from x. Is there any term free from x? The first term has x, so it's not free from x. Second term has x, it's not free from x. Third term has x, so it's not free from x. That means there is no term in this entire n which is free from x. So we just take 0 here, is equal to constant of integration c. So therefore, just integrate this, keep y as constant. So 2e to the power y is constant. Integration of x is x square divided by 2 plus y is constant. So 2 upon y is constant. Again, integration of x is x square divided by 2 plus 1 upon y cube is constant. So 1 upon y cube. 1, integration of 1 is x. Okay. Plus 0 is just 0, and then is equal to constant of integration c. You can just cancel the small things here to make it simple, and therefore you have the solution x square e to the power y plus x square divided by y plus x upon y cube is equal to c. And that's your result that we are looking for, which is the solution of that differential equation. I hope that makes sense. All right, let's look at next example. Here we have dy by dx is equal to negative of this fraction over here. Let's just convert it in the form m dx plus n dy. So therefore we have just multiply this over here. So we have and multiply this over here. So we have minus x square y cube plus 2y times dx is equal to, okay, so minus of this entire thing into dx times dy times 2x minus 2x cube y square. Okay, so therefore just bring everything on the right hand side. So just take this negative on the right hand side and you have x square y cube plus 2y times dx plus 2x minus 2x cube y square into dy. Now this is in the form m dx plus n dy. Okay, let's just take for exactness if it is already exact or not. Mostly it is not. Let's first see delta m by delta y respect to y. So x is constant. So you have x square 3y square plus 2. Okay, derivative of 2y is 2. And let's just differentiate n with respect to x. So you have 2, derivative of 2x is 2, minus, with respect to x, y is constant. So 2y square is constant, derivative of x cube is 3x square. All right, so these both values are not equal, delta m by delta y and delta n by delta x. So obviously it's not exact. But if you notice a pattern here, if you just take y common from here, just take y common. So you have x square y square plus 2 dx plus take x common from here, take x common. So you have 2 minus 2x square y square. Okay, x common 2 minus 2x square y square dy is equal to 0. If you notice something here, there is y along with dx, there is x along with dy. This is in rule number 3. I'll show you the rule, but y along with dx, x along with y, and this is a function of x into y. This is a function of x into y. This is also a function of x into y. Whenever this happens, if you go back to the rules that we have, whenever you have y along with dx function of x into y, x along with dy function of x into y, the integrating factor is straightforward 1 upon mx minus ny. 1 upon mx minus ny. So let's just find that integrating factor. So in this case, the integrating factor is 1 upon mx minus ny, which will become 1 upon, just take m into x. So this is our m, this is our m into x. So multiply that x here. So you have xy, x square y square plus 2 minus n into y. Just multiply y over here. So again, xy 2 minus 2x square y square, which is equal to 1 upon multiply these terms inside and simplify x cube y cube plus 2xy, multiply this inside, minus 2xy plus 2x cube y cube. Okay, this xy times this and this will get cancelled. So this will become 1 upon 3x cube y cube, 1 upon 3x cube and y cube. That is our integrating factor. That is our integrating factor. Now we can multiply integrating factor on both the sides of this equation. We can multiply the integrating factor on both the sides of this equation. So just multiply that integrating factor. So you have y into, just take this equation and multiply 1 upon x 3x cube y cube. So y x square plus 2 divide by 3x cube y cube dx plus x 2 minus 2x square y square divide by 3x cube y cube into dy is equal to 0. That is our a differential equation now which is exact. We know that it is exact for sure because we have multiplied by integrating factor. Simplify this a little bit. So this will become y square. Cancel this. So this will become x square. Okay. So now this is like m dx plus n dy. Okay. This is our new values of m and n that we have over here. So now we can say that our solution, actually before finding solution, just split those values. Okay. Let's just split those values. So we have therefore x cube y square. Okay. So x square y square divided by 3x cube y square plus 2 upon 3 x cube y square times dx plus split this 3x square y cube over here, 2 upon 3x square y cube, then we have minus 2x square y square upon 3x square y cube dy is equal to 0. Let's just cancel the terms that we can. Y square can get cancelled. X square get cancelled and we just left with x here. And over here, x square get cancelled. Y square and this y left here. So therefore, our solution is integration of m dx plus integration of n dy is equal to constant. Okay. Remember, in the first term, we have to take y as constant, and in the second term, we have to take the terms free from x. We have to only take the terms which are free from x. Okay, so integration of, in the first term, we have 1 upon 3x plus 2 upon 3x cube y square dx plus integration. Take only the terms free from x. There are two terms here. This term is not free from x, there is x here, but there is a term which is free from x, which is minus 2 upon 3y. Minus 2 upon 3y dy is equal to constant. Okay. Now just integrate that with respect to x. So we have 1 upon 3 is constant, 1 upon x, integration is log x, plus 2 upon 3 is constant, even y square is constant. And this is just like 1 upon x to the power 3, which is x to the power minus 3. The integration is x to the power minus 3 plus 1 upon minus 3 plus 1. I hope that makes sense. Basic rule of integration. 1 upon x to the power 3 is just like x to the power minus 3. Okay, so it's x to the power minus 3 plus 1 and minus 3 plus 1. Minus 2 upon 3 over here is constant. Integration of 1 upon y is log y is equal to constant c. Just simplify this a little bit and we have our solution. Log x divided by 3 plus 2 upon 3 y square, x to the power minus 2, which is just like 1 upon x to the power 2. And this is just like minus 2. Okay, so we have just like minus 2, like this. Okay, minus 2 upon 3 log y is equal to c. You can just make this plus and make this minus now, and that's your solution of the differential equation. I hope that makes sense. Now let's move on to next example. If you notice this carefully, this is a homogeneous differential equation because the power of this polynomial is 4, power of this polynomial is 4, and power of this polynomial is 4. So that means the dy by dx term is homogeneous in this case. If dy by dx is, and how do we know it is homogeneous? The powers are same. Okay, this is the power 4 polynomial, this is power 4, and this is power 4. Whenever your dy by dx is homogeneous, basically whenever the power of all the terms in the polynomial is same, then the integrating factor becomes 1 upon mx plus ny. So that means dy by dx is a homogeneous function. So integrating factor becomes 1 upon mx plus ny. Okay. So straightforward, we can just say that integrating factor in that case is 1 upon, since uh, dy by dx or this differential equation is homogeneous. Therefore, we can just say that integrating factor is 1 upon mx plus ny, which is So that will become 1 upon m into x. Just multiply that by x. If you multiply that by x, you will get x to the power 5 plus y to the power 4 into x, okay, plus ny, plus ny. So multiply this by y. So you get x into y to the power 4. But remember, there is a negative here. So this will become negative minus xy to the power 4. If you notice, this and this will get cancelled. This and this will get cancelled. And you have 1 upon x to the power 5 as your integrating factor. Very easy so far. Okay. So we can multiply by integrating factor on both the sides. Just so we have, just multiply everything by x to the power 5. So we have x to the power 4 upon x to the power 5 plus y to the power 4 upon x to the power 5 times dx minus x y cube divided by x to the power 5. So this will get cancelled and we left with power 4. Okay, is equal to into dy is equal to 0. Okay, now this is exact. We know that this is exact for sure now. So the solution is integration of m dx, integration of m dx, and this will become okay, this will become 1 upon x plus integration of n dy is equal to c. Okay, so in the first term we take y as constant, so keep y as constant. So we have 1 upon x plus y to the power 4 upon x to the power 5 dx. In n, take the terms free from x. There is no term which is free from x because you have x to the power 4. There is only one term. So we just have integration of 0 dy is equal to c. Okay, so far so good. So therefore we have integration of 1 upon x. We have log x or log x or log mod x, whatever. Let's try log x plus y is constant. So we have y to the power 4. This is just like x to the power minus 5 because it's 1 upon x to the power 5. So this is just like x to the power minus 5. Integration is x to the power minus 5 plus 1 upon minus 5 plus 1 is equal to c. So therefore we have log x. This is minus 4. So this will just become minus y to the power 4 upon 4. And this will just become x to the power minus 4. So that's 1 upon x to the power 4. I hope that's making sense so far. That's the constant of integration c. And that's your solution of this homogeneous differential equation. There are 4 different types of linear differential equations that we are going to learn in this video. There are 2 more which are a little bit of extension of linear differential equation, which is the Bernoulli's linear differential equation and reducible to Bernoulli differential equation. Now let us start with type 1, which is dy by dx plus py is equal to q. I will just clarify here that P and Q both are functions of x. So I'll just write P as P of x to make it clear that it's a function of x, and even Q is a function of x. Okay, so P and Q both are functions of x. Also note that the y is a dependent variable. Okay, y is a dependent variable. Y is a dependent variable and x is independent variable. How do you identify whether it is of the type dy by dx plus py is equal to q, or if it's dx by dy plus px is equal to q? This is, I've seen students getting so much confused here. It's very simple. Remember that the dependent variable occurs only once, or dependent variable is showing up only once because p is a function of x, q is a function of x. So the dependent variable y is showing up only once with power 1. Okay, so that's why you immediately know that it's of the type dy by dx plus py is equal to q. Remember, for how to identify this dependent variable, which is in this case y is showing up only once, and that too with power 1, you immediately know that it's of the type dy by dx plus py is equal to q. In such a case, in this scenario, in this situation, the solution, in order to find solution, you first find something called as integrating factor. You find something called as integrating factor. Integrating factor is given by e to the power integration of p of x dx. We know that p is a function of x. So I'll just write it clearly here that integration of e to the power integration of px dx. That's how you find integrating factor. And then the solution, you write it as y into integrating factor, y into integrating factor is equal to integration of q into integrating factor, q into integrating factor with respect to x. Because remember, q is a function of x, and even integrating factor is a function of x. So we integrate with respect to x and add a constant of integration c. That's the solution of this differential equation, dy by dx plus py is equal to q. I hope this makes sense. One other thing which I want to highlight over here is, remember that this y into integrating factor, this y was a dependent variable. Okay, y was a dependent variable. Why am I telling this again? Because it is always dependent variable into integrating factor. Whatever the dependent variable, you multiply that with integrating factor always. Okay, that's always the case. All right, now let's move on to next type, which is our dx by dy plus px is equal to q. Okay, here if you notice, x is the dependent variable, x is dependent variable, and it occurs only once with power 1. Okay, the dependent variable, which is x, it show up only once, and that too with power 1. If that happens, you immediately now know that instead of y, now x is the dependent variable, and obviously here p is a function of y and q is a function of y. It's exact same approach. They have just switched the variable names. Okay, and students get so much confused here. Okay, the solution is also similar here, like we found before. We first find the integrating factor, which is given by e to the power integration of py dy. Remember that p is a function of y now, so you integrate that with respect to y. And the solution, the way you write, remember that in the previous case, we wrote it as dependent variable into integrating factor. So here we will write x into integrating factor is equal to integration of q into integrating factor dy plus c. Because my dependent variable here is x, which is why I write x into integrating factor. In previous example, in the previous type, y was my dependent variable, so I write y into integrating factor. But here my x is the dependent variable, so I write it as x into integrating factor. Okay, so remember, x is my dependent, x is my dependent variable. So you always write dependent into integrating factor is equal to integration of q into integrating factor. Remember, here q is a function of y, and even integrating factor is a function of y, which is why we integrate this with respect to y, and that's your solution. It is such a simple thing. Now let's try to solve some examples of type 1 and type 2, and then we'll come to type 3 and type 4. All right, let's solve this example. If you notice here, y is the dependent variable. The way we know that is dependent variable is occurring only once, that too with power 1 over here. That's why we immediately know. Therefore, this is of the type dy by dx plus py is equal to q. We immediately know that it's of this type, where where p is 4x upon x square plus 1 and q is 1 upon x square plus 1 the whole cube. We found p and q, which are function of x. In order to solve this, we find something called as integrating factor. Integrating factor is e to the power integration of p dx. Okay, so integrate p with respect to x in the power of that exponential. So which is how you get e to the power integration of 4x upon x square plus 1. 4x upon x square plus 1. You can either do method of substitution here in order to integrate this, or we can just use the standard result. Remember, whenever there is integration of f dash x upon fx, integration of f dash x upon fx. So there is, if the derivative is in the numerator and there is a function, the result of this is log mod fx or log fx, whatever you call it. Okay. So if derivative is in the numerator and the function is in the denominator, the result is log fx. So the way you get here is integration of, if you notice the denominator derivative is 2x, okay, derivative of x square is 2x and derivative of 1 is 0. So the derivative of denominator is 2x and here there is 4x. Let us take 4 out and just write it as 2x over x square plus 1 dx. Now, if you notice, this is exactly f dash x over fx, because this becomes your f dash x and your denominator becomes fx. Your denominator becomes fx. So immediately now you can say this is e to the power 2 times f dash x upon fx. Result is log mod fx. So this is 2 times log of x square plus 1. Log of x square plus 1. Okay, I hope that makes sense. Now, using the property of the log, you can send this 2 in the the power here of power of log. Okay, this 2 can go on the top here. So that will give you e to the power log x square plus 1 the whole square. Okay, and again we'll use the property of log, another property of log. Remember, this is natural log. Okay, remember, this is natural log. So the base of the log is e because it's a natural log. And because the base of the log is e, we know the property of log, that if there is a variable a, and if you have log to the base a x, this is nothing but x. If this base of the log becomes equal to this number here in the base, the result is just x over here. Okay, so here this e and this e are same. So the result will just be this part, x square plus 1 the whole square. So that's the result that you get. So your integrating factor is x square plus 1 the whole square. I hope that makes sense. Now we can just write the solution. We can just say that solution is given by y into integrating factor. Remember, it is always dependent variable into integrating factor. That's how you remember it. Dependent variable into integrating factor is equal to integration of q into integrating factor dx plus c. That's your solution. And integrating factor we already found. So we have y into integrating factor is x square plus 1 the whole square is equal to integration of q. What's the value of q? 1 upon x square plus 1 the whole cube. So 1 over x square plus 1 the whole cube into x square plus 1 the whole square dx plus constant of integration c. Now this x square plus 1 the whole square and this cube will get cancelled. So you'll be left with power 1 in the numerator denominator. Okay. So therefore you get y into x square plus 1 the whole square is equal to integration of 1 over x square plus 1 dx plus c. Now we know this integration 1 over x square plus 1. This is nothing but tan inverse of x. So therefore, y into x square plus 1 the whole square is equal to, this is tan inverse of x. Okay, integration of 1 over x square plus 1 is tan inverse of x plus c, and that is the solution that we are looking for. I hope that makes sense. This is such a beautiful question that we are solving right now. If you notice this differential equation that we need to solve, y is occurring multiple times in multiple places, but x is occurring only once with power 1. Okay, x is occurring only once with power 1, occurs once with power 1. What that tells you is whatever occurs with power 1 just occurs once with power 1 is your dependent variable. Okay, so your x in this case is a dependent variable, is what we are able to conclude so far. Dependent variable. Since x is occurring only once and it's a dependent variable, we need to convert it in the form dx by dy plus px is equal to q. So we need to convert it in the form dx by dy plus px is equal to q. That means we want dx by dy separate. Okay, if you want to separate dx by dy, we have to divide the entire equation by 1 plus sine y, because dx by dy we want to separate. Okay, so you have 2y cos y divide by 1 plus sine y minus x and sec y plus tan y divide by 1 plus sine y. I hope that makes sense. Now let's bring this term with x on the left hand side, just like we have in this dx by dy plus px. So therefore we have dx by dy plus x times sec y plus tan y divided by 1 plus sine y is equal to 2y cos y divided by 1 plus sine y. Okay, now this is of the form dx by dy plus px is equal to q. That tells you that this whole thing is p and this whole thing is q. So therefore we have p is equal to sec y plus tan y divided by 1 plus sine y and your q is 2y cos y divided by 1 plus sine y. Now let's try to find integrating factor. We know that integrating factor is given by e to the power integration of p dy, because p is a function of y now. So it's integration of e to the power integration of p dy. Let's try to find integration of p dy first. Okay, since it's a bigger function, just let's find it separately. So we say integration of sec y plus tan y divided by 1 plus sine y and with respect to y. How do we integrate this? I see the best approach that I can see is convert everything into sine and cos. So what we can do is we can just write this sec y as 1 upon cos y. This tan y, I can write it as sine y upon cos y and divide by 1 plus sine y. So we just convert everything into sine and cos. Now in the numerator, what I can have is integration of this denominator is same, so the numerators get added. So I have cos y and I have 1 plus sine y divide by 1 plus sine y and I have dy. Very easy so far. Okay. Now if you notice this 1 plus sine y and 1 plus sine y will get cancelled. So basically you are left with integration of 1 over cos y dy, which is nothing but integration of sec y dy, sec y dy. Now we know by formula integration of sec theta or sec y is log of sec y plus tan y. Log of sec y plus tan y is, we found that integration of p dy. So we found the integration of p dy already. Now we can substitute that integration in our integrating factor. We can substitute that in our integrating factor. So our integrating factor will become, therefore, our integrating factor will become e to the power log of sec y plus tan y, log of sec y plus tan y. Now, since it is natural log with a base e, natural log always has the base e, we can use the property of the log. Okay, this log and e terms will get kind of cancelled, and you are left with sec y plus tan y, which is your integrating factor. Now, since we have integrating factor, let's write the solution. Let's try to write the solution. We know that solution is now dependent into, so remember, solution is always dependent variable into integrating factor. In this case, dependent variable is x. So we write x into integrating factor is equal to integration of q into integrating factor. And remember, q is a function of y, integrating factor is a function of y. So we integrate with respect to y and plus c. Now let's substitute the values that we have. So we have therefore x into integrating factor is sec y plus tan y is equal to integration of. Let's substitute the value of q. What's the value of q? So the value of q is 2y cos y upon 1 plus sine y. It's 2y, q is 2y cos y divided by 1 plus sine y into sec y plus tan y. Sec y plus tan y. And this is dy plus constant of integration c. It's not that hard to integrate this. We just have to convert this into sine and cos. We just have to convert those variables or those trigonometric functions into sine and cos. So we have 2y cos y divided by 1 plus sine y. And let's write this as this sec y is 1 upon cos y, 1 upon cos y, plus this tan y is sine y upon cos y. This is dy plus that constant of integration c. Let us simplify this a little bit. This will become integration of 2y cos y divided by 1 plus sine y. The denominators are same, so we can just add up the numerators. So we'll get 1 plus sine y divided by cos y into dy plus c. If you notice, this 1 plus sine y and 1 plus sine y will get cancelled. This cos y and this cos y will get cancelled. So basically you are left with integration of 2y dy plus c. 2y dy plus c. Now this can be written as 2 is constant, can come out of integration. So you can just write 2. Integration of y with respect to y is y square divided by 2, because this is y to the power 1. So we get y square divided by 2 plus c. And in the left hand side, we have x into sec y plus tan y. And that's your solution of differential equation that we are looking for. All right, let's look at next type, which is type 3 and type 4, which is reducible to linear differential equation. So the differential equation that will be given to you will not be linear by default. You will have to just do a small thing and convert it to linear. Okay, let's see what do we mean by this. So the original form that we know is dy by dx plus py is equal to q form. That's the original linear differential equation form in y, because y is the dependent variable. Now instead of y, they can give you fy. But when they give you fy instead of y, they will also give the derivative of the product of dy by dx. Okay, so instead of y, they will give you fy, and they will also give you derivative of f dash y. It's just like saying the derivative of y, which was 1, which was present here always, and we did never noticed it. Okay, so just like in linear form, the derivative of y was present here. We can have fy, and there could be f dash of y here. Okay, in order to solve this, or in order to convert it to linear, we call it reduction to linear. We can reduce this differential equation to linear by just saying this fy function. We can just say that fy is equal to t. We can just say fy is equal to t. And when you put that fy as t, differentiate this equation with respect to x, differentiate this fy is equal to t with respect to x. Okay, so if you differentiate with respect to x, derivative of fy with respect to x is f dash of y into derivative of y with respect to x, which is dy by dx by chain rule, is equal to dt by dx, derivative of t with respect to x. Okay, here I applied chain rule to say this derivative is f dash of y and derivative of y is dy by dx with respect to x. Okay, so we can make that substitution here. So this f dash of y dy by dx is dt by dx. So I can just say this is dt by dx plus p times t. This is t. Okay, I'm making the substitution. Fy is equal to t is equal to q. So that is now linear in t. This is linear differential equation in t. Notice that now t occurs only once with power 1, which is why it is linear in t. The other type, which is type 4, is very similar to the form dx by dy plus px is equal to q. Why it is similar? Because instead of x, here we have fx, and instead of 1 over here, we have function derivative of fx, which is f dash of x. Okay, you can convert it to linear. You can reduce this equation to this type by saying put fx is equal to t. Put fx is equal to t. So you put fx is equal to t. Remember that now we are differentiating with respect to y, okay? Because we want dx by dy. So we'll differentiate this with respect to y. This is very important step, okay? I have seen students make mistake here. This is very important step. Note this. Now if you differentiate this with respect to y, derivative of fx with respect to y is f dash of x into dx by dy. So you differentiate this and you take derivative of x with respect to y by chain rule is equal to dt by dy is equal to dt by dy. Now we can make that substitution over here in this equation, and therefore we get dt by dy plus p into t, because this fx is now t, is equal to q. Now remember that this is a linear differential equation in t. Linear in t, because t is your dependent variable now and y is your independent variable, which is why it is always helpful to look it as dependent variable and independent variable rather than just looking at it as x and y. Always call it dependent and independent. Okay, that will just make your life so easy. Now let us look at some examples of reducible to linear form. Now let's solve this example. Y divided by dx plus 4x divided by 3 minus y square over 3x is equal to 0. Okay, This is not of the type linear because there is not a single variable here that occurs only once. Okay, there is x which occurred two times and even y occurs two times. But if you notice the derivative of y square, the derivative of y square is 2y, but there is no 2, but there is y present. Okay, so the derivative of y square is easily manageable over here. Therefore, it is of this type. Therefore, because there is derivative, because there is fy and there is f dash of y. Okay, so it's of this type. F dash y dy by dx plus pfy is equal to q. So let's see. Let's take q on the other side. So x is our dependent variable. Let's take 4x plus divide by 3 on the other side. So therefore, we have y dy by dx, y dy by dx minus y square into 1 over 3x is equal to minus 4x divided by 3. I hope that makes sense. Now we can convert this to linear by putting y square is equal to t. Why do we put y square is equal to t? Because the derivative of y square is present over here. Okay. Always remember that we have to differentiate this always with respect to independent variable. In this case, independent variable is x. So we differentiate this with respect to x. Differentiate this with respect to x. Even here, remember, we always differentiate with respect to independent variable. Your independent variable is y. We always differentiate with respect to independent variable. So if you differentiate with respect to x, derivative of y square with respect to x, it is 2y into dy by dx. 2y into dy by dx is equal to derivative of t with respect to x is dt by dx. The term that I'm looking for here is y dy by dx. So y dy by dx here is given by y dy by dx. You can just divide by 2 here. So you'll get half dt by dx because that's the term I'm looking for, y dy by dx. Okay. So therefore I have here y dy by dx is half dt by dx. Okay. So therefore you can make that substitution now. So therefore you can eliminate y from here and convert it to t. So this y dy by dx is half dt by dx minus y square is t. So this is t times 1 over 3x is equal to minus 4x divided by 3. Now if you notice this is linear in t. This differential equation is linear in t. Why is it linear in t? Because t is occurring only once with power 1 now. Okay, so you can easily solve it by linear in t concept. Okay, just let's remove this half from here. So multiply by 2. So therefore we have dt by dx. Just multiply entire equation by 2 minus t into 2 divided by 3x is equal to minus 8x by 3. Now this is of the form dt by dx plus pt is equal to q. Okay, dt by dx. This is just like dy by dx plus py is equal to q. Okay, where p is equal to minus 2 over 3x and q is equal to minus 8x over 3. Now we can just solve it like we did for linear. Let's quickly solve it. Let's first find integrating factor. Integrating factor is e to the power integration of p dx, okay, which is equal to e to the power integration of minus 2 by 3x dx. Okay, so which is now equal to e to the power. This minus 2 by 3 is constant and can be taken out of integral. So this is minus 2 by 3 integration of 1 by x dx. So that will become e to the power minus 2 by 3. Now integration of 1 by x we know is log x. This will become log x. All right. Now this is equal to e to the power. Now this minus 2 by 3, using the property of log can be taken in this power. Okay. So that will become log of x to the power minus 2 by 3. Log of x to the power minus 2 by 3. Also remember that this is a natural log and natural log has the base of e, which is why this log term and this e term, this whole thing will get cancelled and you will be left with x to the power minus 2 by 3, which is your integrating factor. All right. Now that we know integrating factor, our solution is dependent variable into integrating factor. Always remember the solution is always dependent variable into integrating factor. In my case, dependent variable is t into integrating factor. Why is it t? Because our differential equation, a linear differential equation was linear in t. So t is my dependent variable. Okay, so it's t into integrating factor is equal to integration of q into integrating factor, okay, dx plus c. Because my q is a function of x and even integrating factor is a function of x. Q is a function of x and integrating factor is a function of x, which is why I integrate with respect to x. So therefore, remember t is nothing but y square. T is y square is what we had made substitution. If you remember, if you just look above here, we just put y square as t. Okay, so that's what the substitution that we made. So we can resubstitute back now. So y square into x to the power minus 2 by 3 is equal to integration of q into integrating factor. So q is what? Q is minus 8x by 3. Q is minus 8x by 3 and integrating factor is x to the power minus 2 by 3 dx plus c. Okay, so therefore y square into x to the power minus 2 by 3 is equal to this minus 8 by 3 is constant, can be taken out of integration of, and here we can just apply the law of indices. So this is x to the power 1 times x to the power minus 2 by 3. We can just write this as, this can be just written as x to the power 1 minus 2 by 3 by the law of indices. Okay, if the base is same, the power gets added up. So this will become x to the power 1 by 3. Okay, so we can just now complete our integration. This is very easy now. Y square into x to the power minus 2 by 3 is equal to minus 8 by 3. Now integration of x to the power 1 by 3, this is just like x to the power n. So the integration is x to the power 1 by 3 plus 1 divided by 1 by 3 plus 1 plus c. Okay, using the formula of integration. So therefore we have y square into x to the power minus 2 by 3 is equal to minus 8 by 3 x to the power 1 by 3 plus 1 is 4 by 3. Okay, divide by 4 by 3. Okay, plus c. Now this 3 is in the denominator and this 3 is in the denominator's denominator. So both can get cancelled. This 4 can get cancelled with 8 and you will be left with 2. So therefore you have the result. Therefore you have y square into x to the power minus 2 by 3 equal to minus 2 into x to the power 4 by 3 plus constant of integration c, and that is the solution that we are looking for. I hope that made sense. All right, let's look at this next example, another beautiful one that will use all the concepts that we have been studying. If you notice this equation, is it linear or not? Let's first find that out. Is x occurring only once? No, x is occurring once here or twice here and twice here. So it's not occurring once. Even y is occurring multiple times. Okay, y is occurring 2 times here. So this is not a direct linear, but we'll have to reduce it to linear. Okay, now in order to reduce it to linear, we have two options. We can either have f dash y dy by dx plus p of fy is equal to q, and the other option we have is and f dash x dx by dy plus p into fx is equal to q. So these are the two options that we have studied and that we have. Okay, let's see which type it is. If you notice, fy derivative is present, fx derivative is present. Is there a function whose derivative is already present over here? Okay, let's look at it carefully. So if you notice this part, x into e to the power x, if you notice this, the derivative is somewhere this function. Why is this? Let's see. If you look at that x e to the power x, x e to the power x, let's take derivative. Okay, let's take derivative of this. You have to apply product rule in order to differentiate this. The derivative is, so you keep, this is just like u and v. So u derivative of v, so x into derivative of e raised to x is e raised to x plus u v as it is, e raised to x, derivative of x is 1. This is just like product rule or UV rule of derivative. So you get e to the x common x plus 1. So if you notice this, if this is your fx, this is your f dash of x. So somewhere it is of this type because you have fx present and f dash of x present. It's a very good question. Okay. So since you have it's of this type, you need to convert, you need to first find dx by dy. You need to first find dx by dy here. So in order to find dx by dy, let's just shift this term on the right hand side. So therefore, I have uh, e to the power x, x plus 1 into dx is equal to minus of, or if you shift it on that side, just the signs will change. This negative will become positive, x e to the power x, and this positive will become negative, y e to the power y times dy. Okay, that's the situation that you have. I'll just make a partition over here. All right. So therefore, here we need to find dx by dy because we already identified is of this type. So we get dx by dy is equal to x into e raised to x minus y into e raised to y divide by e raised to x into x plus 1. Okay. Now, since we have dx by dy, in dx by dy, we need f dash of x, which was this function here. So we have to multiply this function on this side now. So therefore, we have e raised to x into x plus 1 into dx by dy is equal to x into e raised to x minus y into e raised to y. Okay. I hope it's making sense so far. So therefore, I'm just trying to convert it to this type. Okay. So I have f dash x dx by dy. Now I need p into fx. I need p into fx is equal to q. Okay. fx was this function. Fx was x into e raised to x, right? Because this was fx. So fx was this. So I need this on the left side. So I have e raised to x into x plus 1 into dx by dy minus x into e raised to x is equal to minus y into e raised to y. Okay. Now this is of the type this f dash x. So this is f dash x plus p into fx. So you see fx is equal to q. Okay. So therefore, in order to solve this, remember that if you want, there is a plus here, you can actually make it look exactly like this just by doing like this. Dx by dy plus minus 1 into x into e raised to x is equal to minus y into e raised to y. So what happens by doing this is just exactly of the form p into fx. Okay, this is exactly of the form p into fx. So this is your fx. Remember, this is your fx. This is your f dash of x. This is your f dash of x. Okay, and this will become your p and this will become your q. I hope that makes sense that how we converted it to this type. Now, since we converted to that type, we can solve this by doing put fx is equal to t. We can just put fx is equal to t. So therefore, we put x into e raised to x as t. We put x into e raised to x as equal to t. So we get x into e raised to x. So differentiate this with respect to, we always differentiate with respect to independent variable. Independent variable here is y. So differentiate this with respect to y. So therefore, let's apply UV rule here. Okay, UV rule. So x the way it is into derivative of e raised to x is e raised to x plus e raised to x the way it is, derivative of x is 1. Okay, and then we have to also do dx by dy by chain rule. We also have to multiply, since we are differentiating this with respect to y, we also have to write dx by dy by chain rule is equal to derivative of t with respect to y is dt by dy. Okay, dt by dy. So now you can see that therefore you can take e raised to x common here, e raised to x into x plus 1 into dx by dy is equal to dt by dy. So we have this replacement of this. This whole thing is now dt by dy. So therefore, dt by dy plus minus 1 times this is fx, which was t, times t is equal to minus y into e raised to y. Minus y into e raised to y. All right, now this is of the linear form where y is independent and t is dependent. So we find integrating factor by saying e to the power integration of p into d. Okay, now remember that p and q both are function of independent variable. Okay, p and q are both functions of y. Okay, don't make a confusion here because it's p, the value of p is minus 1 over here. So you don't easily see that if it's a function of y. But remember, in this case, p and q both are function of y because y is dependent variable. Okay, p and q are both always functions of independent variables. So e to the power minus 1 integration of minus 1 dy, which is e to the power integration of minus 1 is y. Okay, integration of 1 is y and this minus. Okay, and that's your integrating factor, e to the power minus y. Okay, now the solution is, now the solution that you can get is always dependent variable into integrating factor. Solution is always dependent. In this case, dependent is t. So t into integrating factor is equal to integration of q into integrating factor into dy plus c, because q and integrating factor both are functions of y. So we integrate with respect to y. Okay. And remember that t was x into e raised to x. T was x into e to the power x. So you can substitute that back. So therefore, x into e raised to x, integrating factor is e to the power minus y is equal to integration of q into integrating factor. What was q? Here that q is minus y into e to the power y. So minus y into e to the power y. Integrating factor is e to the power minus y dy plus c. So we can just substitute the value of q, which is this integrating factor, which is this here. Okay, from here. All right, now let's just quickly write it down. So therefore, we have x into e to the power. Now here, since the base is same, the power will get added up. So this will become x minus y is equal to integration of. Now e to the power y, this e to the power minus y. Okay, so e to the power minus y is just like 1 over e to the power y. So this and this will get cancelled. So you have integrate, this minus can be taken out, y dy plus c. So therefore you have x into e to the power x minus y is equal to minus y square divided by 2 plus, so integration of y to the power 1 is y square divided by 2, and that's your solution that we are looking for. Such a beautiful and important question it is for Mumbai University. Okay, I hope that made sense. Bernoulli's differential equation is of the form dy by dx plus py is equal to q times y to the power n. Okay, remember here y is a dependent variable, y is a dependent variable, and x is a independent variable. X is a independent variable. How do you identify Bernoulli's differential equation? Bernoulli's differential equation, you will notice that the dependent variable will occur 2 times, will exactly occur 2 times. One time with power 1, one time with power 1. So this has power 1, right? So this has power 1, and one time with power n, one time with power n. Okay, that's how you see Bernoulli's differential equation. That's how you identify Bernoulli's differential equation. Now, in order to solve this type of equation, what you have to do is you have to divide by, remember, we'll convert it to linear. So linear, the form of linear is dy by dx plus py is equal to q. Okay, that's the form of the linear that we want to convert it to. So on the right side, we just want q. So we don't want this y to the power n on the right hand side. So what we do is basically we divide by y to the power n on both the sides. If you divide by y to the power n, so you get 1 over y to the power n dy by dx plus p y divided by y to the power n is equal to q. So you divide by y to the power n on both the sides. Okay. Now we'll make some adjustments here. This is y to the power 1, y to the power n. This whole thing, this is going to become y to the power 1 minus n, right? By the law of indices, that's going to become y to the power 1 minus n. All right. If we want py, so we want a single variable with power 1. Okay. What we are going to do now here, we'll put that y to the power 1 minus n as t. Why do we put that as t? Remember, we just want a single variable here, just like y. Okay. So here I have y to the power 1 minus n. So what I do is put that y to the power 1 minus 1 minus n, sorry, as t. The moment you put y to the power 1 minus n as t and you differentiate this, let's differentiate this with respect to, remember, always we differentiate with respect to independent variable. Independent variable in this case is x. So always differentiate with respect to independent variable, which is x. So we get derivative of this with respect to x is 1 minus n y to the power 1 minus n minus 1. In differentiation, we reduce the power by 1. Take the power down, reduce the power by 1. And by chain rule, we also take the derivative of y with respect to x. Okay. So derivative of y with respect to x is dy by dx. Okay, because we are differentiating with respect to x, and this is y, we in the end by chain rule we also have to take dy by dx, which is the derivative of y with respect to x, and derivative of t with respect to x is dt by dx. Okay, now if you make some cancellations and adjustments, this 1 and 1 will get cancelled. If you notice here, if you notice over on this side, if you notice on this side, you already have 1 over, so this is just like y to the power minus n. This is just like y to the power minus n. So you have y to the power minus n into dy by dx. You already have that here, y to the power minus n into dy by dx. So what you do, just write y to the power minus n into dy by dx is equal to, take this 1 minus n on the other side or divide by 1 minus n. So you get 1 over 1 minus n into dt by dx. The moment you do this substitution, this equation is going to, the linear, the Bernoulli's equation is going to look like, therefore, this first term is going to become 1 over 1 minus n into dt by dx plus p into, this is t, okay, plus p into t is equal to q. And that is your now linear differential equation. Now, if you notice, we have dependent variable is t and independent variable is x, and dependent variable is occurring only once with power 1. If you just multiply this entire equation by 1 minus n, n is a constant value, okay, just like power 2, power 3, and so on. If you just multiply it by 1 minus n, this will just become linear differential equation, linear in t, linear in t. Let's look at example of this to make it more crystal clear. All right, let's look at this example. Dr by d theta is r tan theta minus r square upon cos theta. First thing we have to do is identify which is dependent variable and which is independent variable. If you notice over here, this r is occurring two times. One is r and r square versus theta is, there is function of theta like tan theta, cos theta. So it cannot be, theta cannot be dependent. Okay, in this case, r is occurring two times, one with power 1 and one with power 2. Okay, so in this case, R is a dependent variable, R is dependent variable, and theta is independent variable. Okay, and that means they are, the format that they have written is correct. Dependent variable over independent variable. Okay. Okay. Remember, you cannot look at dr by d theta and say that r is dependent and theta is independent. They could have written it other way around too. Okay. To confuse you, they could have written it other way around. But you always look at how many times a variable is occurring. If it was occurring only once with power 1, it was a linear differential equation. Here it is occurring twice, one with power 1, one with power n, which is 2 in this case. It's a Bernoulli differential equation. Okay, and so on. Uh, so let's convert it to the Bernoulli type. Remember that Bernoulli type was dy by dx plus py is equal to q into y to the power n. Okay, so this y to the power n term is on the right hand side. This term is on the right hand side, but this term is on the left hand side, py. So let's take it on the left hand side. So dr by d theta minus r tan theta is equal to minus r square upon cos theta. Okay. Don't get confused between y and x. Just look it as dependent variable and independent variable, and it will be very easy. Now, in order to solve this Bernoulli, remember we divide by y to the power n. So in this case, we divide by r square on both the sides. Divide by r square on both the sides. So therefore, what do we get? 1 upon r square dr by d theta minus r upon r square tan theta is equal to minus 1 upon cos theta, which is sec theta. This r square will just get cancelled, and 1 upon cos theta will become sec theta. Okay, and then this r will get cancelled, and you will be left with 1 upon r. Then what we can do, if you notice, derivative of 1 upon r is minus 1 upon r square. Okay, so we put 1 upon r is equal to t, or you can put minus 1 upon r is t. That's fine too, either way. Okay, so you put minus 1 upon r as t. The moment you put minus 1 upon r as t, you differentiate with respect to x, with respect to, sorry, we differentiate with respect to independent variable. In this case, independent variable is theta. So we differentiate with respect to theta. Always remember, we always differentiate with respect to independent variable. Okay, so we differentiate with respect to theta. So therefore, remember this is nothing but r to the power minus 1. Okay, so you have minus r to the power minus 1. So then you have minus r to the power minus 1. Derivative of that is minus 1 r to the power minus 1 minus 1. Okay, and you are differentiating with respect to theta. Since you are differentiating with respect to theta, derivative of r with respect to theta is dr by d theta by chain rule. Okay, you also write derivative of r with respect to theta, and on the right side you just write derivative of t with respect to theta dt by d theta. Okay, so therefore this negative and negative is going to become positive. This is going to be r to the power minus 2. That's going to be r to the power minus 2. So that's just going to be 1 upon r square, because r to the power minus 2 is nothing but 1 upon r square. Okay, and dr by d theta, I hope that makes sense, is equal to dt by d theta. Okay, now if you notice this, you can easily make that substitution over here. So basically, you can replace r, you can replace the dependent variable r with our new dependent variable t. You're basically making a replacement of dependent variable. You're not doing anything with the independent variable. You'll still have the same independent variable. It's just the dependent variable was earlier r, now it will become t. So this term 1 upon r square dr by d theta is going to become dt by d theta, okay, minus or plus, because we are putting minus 1 upon r as t, okay, so this is t. So plus t into tan theta is equal to minus sec theta. I hope that makes sense. This minus 1 upon r we are putting as t. So we have plus t into tan theta is equal to minus sec theta. Now this is linear in t. This is linear in t because t is occurring once with power 1. This is a differential equation which is linear now in t. So now we find the first thing is integrating factor. Integrating factor is e to the power integration of p. Okay, before integrating factor, let's just write it. Let's just find the value of p and q first. Okay, let's just write it down. We already know. So p is here. This is our p and this is our q. So p is tan theta. Q is minus sec theta. Okay, so now let's find integrating factor. Integrating factor is e to the power integration of p d theta. Remember here we always integrate with respect to the independent variable. Okay, differentiation and integration both happen with respect to independent variable always. You never integrate or differentiate with respect to dependent variable. You always do that with respect to independent variable. Okay, so you have e to the power integration of p is tan theta d theta. Now integration of tan theta is log sec theta. Log sec theta. Okay, that's the formula of integration. Remember that this is a natural log. Okay, this is a natural log. Since this is a natural log, this whole term e log e will kind of get cancelled and you will be left with sec theta. That's the property of log. That if this base and this base is same, if these two bases are same, then you are left with the main function of the log, which is sec theta here. Okay. All right, now we have solution. We can just write solution by formula. Solution is, remember, solution is on the left hand side, we have dependent variable into integrating factor. In this case, dependent variable is t now. Okay, now because it was linear in t. So we have t into integrating factor is equal to integration of q into integrating factor. Remember, we always integrate and differentiate with respect to independent variable, which is theta now, which is theta. The independent variable is have been theta all the time. Okay, q into integrating plus constant of integration c. All right, now let's substitute those values. T into integrating factor is sec theta. So T into sec theta is equal to integration of q is minus sec theta. Integrating factor is sec theta plus c. So therefore, T into sec theta. Okay, remember T was minus 1 upon R. Okay, remember T was minus 1 upon R. We can substitute it back now. Now that we have solved, T was minus 1 upon R. So minus 1 upon r sec theta is equal to, this minus can be taken outside of integration. So you have minus sec square theta d theta plus c. There is also d theta here. Okay. So you have therefore minus 1 upon r sec theta is equal to integration of sec square theta is tan theta. Okay. By formula, because the derivative of tan theta is sec square theta. That's the logic. Plus c. And that's your solution that we are looking for. I hope that makes sense. All right, now let's solve this one. It's a very interesting one again. In this question, if you notice carefully, let us do a few things here before we start. Let's just multiply this inside first. So therefore, we have xy plus x square into y cube plus x square into y cube into dy by dx is equal to 1. Why is this an interesting question? Is because the concept of dependent and independent variable that we learned becomes very evident here. Okay, what do I mean by that? Let's see. If you try to convert it to dy by dx form, if you see here, x is occurring two times, one with power 1 and one with power 2. Even y is occurring two times. So it's very hard to judge in this case whether it's x is dependent or y is dependent or which is independent. Okay. What is independent and what is dependent? It's a little bit trickier in this case. But it's no longer trickier when you notice one thing here, that if you kind of try to find dy by dx, if you try to find dy by dx, this is going to become 1 over xy plus x square y cube. The moment you notice this, this kind of goes in the denominator now. This term goes in the denominator. So you can no longer convert it to form py is equal to q or something like that because it's now in the denominator. Rather, what you can do, if you just look at, if you just send this dx and dy here, so you just say xy plus x square y cube, you just write it in the term of dx by dy. So just multiply that dx by dy on the other side. So you have is equal to dx by dy. Now, if you notice, this starts to make sense. It is starting to make sense that x is our dependent variable, y is independent variable. Why? Because now this is in the numerator and you can easily convert it to the form dx by dy now plus px is equal to q. Because if you write it as dy by dx, that term will go in the denominator, so you can no longer convert it to this form. Okay, so it's very important thing to note here that you have to convert it in the form dx by dy. So now if you write, so therefore you have dx by dy. Remember, if x is dependent variable, the form that we are going to convert is dx by dy plus px is equal to q into x raised to n. So that x raised to n term should be on the right hand side, So we will keep this term on the right hand side, x square into y cube on the right hand side. Okay. So we keep it here. We'll just bring this term on this side. So xy can come here. So dx by dy minus xy is this. Now this is in the form dx by dy plus px is equal to q. Let's quickly write down. So since dx by dy plus px is equal to q. Okay. Sorry, q into x raised to n. This is q into x raised to n on this side. Let's quickly, we know that in order to solve such an equation, we divide by x raised to n on both the sides. Let's divide both the sides by divide by x raised to n. So in this case, it is x square. So divide by x square on both the sides. So if you divide by x square, you have therefore 1 over x square dx by dy minus x over x square into y is equal to y cube on this side. This x and this x will get cancelled. You will be left with 1x. So therefore, you will be left with 1 upon x square into dx by dy minus 1 upon x into y is equal to y cube. Okay. Now, you can just say 1 upon x is equal to t, or just put minus 1 upon x as t. What will happen by putting minus 1 upon x as t is just differentiate now with respect to, you always differentiate with respect to independent variables. So we differentiate with respect to y. So if we differentiate with respect to y, we have minus 1 upon x differentiation is, so this minus 1 upon x can be written minus x to the power minus 1 is equal to t. So the differentiation is minus 1. So there is this minus already. Then there is minus 1 x to the power minus 1 minus 1. Okay. And then since you are differentiating with respect to y, you write dx by dy is equal to derivative of t with respect to y is dt by dy. Okay. Now therefore you have this is just going to become plus, and then you'll have x to the power minus 2 into dx by dy is equal to dt by dy. And now this x to the power minus 2 is nothing but 1 upon x square. So therefore you have 1 upon x square dx by dy is equal to dt by dy. All right, now let's make a substitution here. This can be replaced with dt by dy minus. So this minus 1 upon x is t. So you can just write it as plus t times y is equal to y cube. I hope that makes sense because this is t now. All right, now that we understand this much, we can just solve it like linear. We can just say this is where p is now. P is y and q is y cube. Q is y cube. Okay, remember that this is of the form dt by dy plus pt. This is of the form dt by dy plus pt is equal to q, because t is the dependent variable, it occurs once. Okay, so this is your p and this is your q. Okay, now let's try to find the integrating factor. Integrating factor is e to the power integration of p with respect to y, because y is independent variable. So e to the power integration of y dy, which is e to the power y square divided by 2. Now let's try to write the solution. Very easy now to write the solution. Now the solution will become, on the left side we have dependent variable into integrating factor. Dependent variable is our t. So we have t into integrating factor equal to integration of q into integrating factor with respect to y, because y is our independent. Okay, we always integrate and differentiate with respect to independent variable. Okay, if you notice I'm saying those things again and again, that means it's a message for you that you have to remember those things now. Okay, so you kind of start to get, as you practice, you'll get more comfortable in using those terms like me. So therefore you have t into our t was, you can just substitute it back. Our t was minus 1 upon x. T was minus 1 upon x. So we can just substitute minus 1 upon x into integrating factor is e raised to y square by 2 is equal to integration of q into integrating factor. Q is y cube and integrating factor is e raised to y square divided by 2 dy plus c. All right. Now, in order to integrate this right hand side, in order to integrate, let's call that integral as I, so that we can integrate it. Let's call that integral as I. So if I is integration of y cube e raised to y square divided by 2 into dy. All right, now in order to integrate this, first let's write it like this. Y square into y into e raised to y square by 2 dy. Why I'm doing this is I'm eventually now going to do method of substitution here. Why will I do method of substitution? Because this is a composite part. This part is, I cannot integrate this like this directly. What I'll have to do is I'll have to put this as some other variable. Let's say t1. I already used t, so I will not reuse it. Let's just put that as t1. So you put y square by 2 is equal to t1. Y square by 2 as t1. Therefore, you differentiate. Let's differentiate this with respect to y. Differentiate this with respect to y. So therefore, this half is constant. Derivative of y square with respect to y is 2y. Derivative of t1 with respect to y is dt1 by dy. dt1 by dy. This 2 and 2 will get cancelled. Okay, and therefore, just multiply this dy on the other side. So we have y dy is equal to dt1. Y dy is dt1. If you notice here, this y times dy is dt1. This is t1, okay, and this y square is nothing but 2t1, right? Y square is nothing but 2t1. So we can convert the entire integral now in terms of t. So if we convert the entire integral in terms of t, we have integration of y square is 2t1. Then we have y dy. Y dy is dt1. Y dy is dt1, and this is e to the power t1. E to the power t1. So 2 is constant, we can take it out of integral. We have basically t1 into e to the power t1 dt1. Now this is product rule of integration. Okay, it's a very beautiful question. It is using a lot of concepts of calculus from all over the place. Now this is the product rule. Now if you remember, for anyone who remember product rule, let me just revise. If it is u v dx, if it is u v dx, product of, so the formula for this is u into integration of v dx minus integration of derivative of u into integration of v, okay, and again you have to write dx for this bigger integral and plus c. That's the formula. That's the formula. And in order to select u and v, if you remember, we do something called as islet. We do something called as islet, okay, where I stands for inverse, L stands for log, A stands for algebraic, T is trigonometric, and E is exponential, okay, something that we have learned in integration chapter already. Whatever comes first is u. So in this case, this is algebraic function, this is exponential, okay. So this is algebraic and one is exponential. So algebraic is first, so algebraic becomes u, exponential becomes v. So this is u, this is v. I hope all that is making sense. You should know a little bit of integration to do differential equations. So therefore, this is 2 times. Let's put a bracket because there is 2. U into integration of v. U into, so u into t1 into integration of e to the power t1 dt1 minus integration. Derivative of u. Derivative of u. Derivative of t1 with respect to t1 is 1. Integration of v. Integration of v is e to the power t1 dt1. Okay, I hope that makes sense. And let's write another dt1. So this dt1 belongs to this small integral and this dt1 belongs to that big integral. We are almost done solving. So we have 2 into t1. The integral of e to the power t1 is e to the power t1 minus, again, 1 times, this is again e to the power t1. Integral of e to the power t1 is e to the power t1. So you again have integral of e to the power t1, okay, dt1. This is equal to 2 times t1 into e to the power t1 minus integral of e to the power t1 is e to the power t1 and plus the constant of, we are already adding the constant of integration in the differential equation. So we don't need to add it here. Now t1, remember that t1 was y square divided by 2. T1 was y square divided by 2. So we can make that substitution back. Y square divided by 2 e to the power y square divided by 2 minus e to the power y square divided by 2, and that's your integral I. That's your integral I. And you can just resubstitute that integral uh, in that differential equation and you have the result. I hope that is making sense. If you just look at that integral and then substitute it back over here, okay, over here, that's your final result. I hope that makes sense. I won't rewrite it, but basically you just have to put that value over here, okay, the value that we found here, because this is your I. Thank you so much for watching till the end. Please do like the video, share the video to your network. Please do comment your questions. I love when you comment. I love when my students comment and ask questions. So please do comment. I will reply to each and every comment. I promise. Okay. Take care. Have a nice day.